Okay, so recapping what we learned on Monday and refreshed last class on Tuesday. All right, so looking at arithmetic sequences. Remember, arithmetic sequence goes hand in hand with linear function. It's like saying the same thing because the pattern going from term to term, we can see that we're adding and subtracting. It's consistent. It's like our common difference, also known as our slope, where we're looking at just those y values again. Versus a geometric sequence goes hand in hand with exponential functions. The pattern that we'll see is where we're multiplying and dividing by some constant, again, continuously multiplying divided by the same term. That's called our common ratio, also known as our slope for an exponential function, specifically, again, looking at those y values. All right, these are different parent functions. It kind of looks like it's like a whole spotlight thing. These are different parent functions for functions. So functions just like for like different graphs. So we're focusing again on linear, and we're focusing on exponential down here. Exponential and linear. Those are the two that we're focusing on. But this is just showing other different functions. Function just means it has a 1-to-1 ratio, but we're not going super in depth with that. We're just focusing on linear and exponential functions. Okay, so we've got some notes here. Let me get my notes. All right, so different stuff here. We're looking at our A value versus the B value. This is our setup for an exponential function. So remember for I don't know why I can't do black, but remember for a linear function, that was like how we would set it up was like y equals mx plus b. Remember that was like our setup for linear. This is like same idea. This is the setup for now, just exponential. So the A value is always our y-intercept, or also known as the very first term in like our sequence and in our table. It's like first term. Whenever we want the y-intercept, that's meaning it's always when x equals 0. So when x equals 0. So remember, thinking on like a y-intercept all along our y-axis, right? All along the y-axis, x is always going to be 0. All right, so y-intercept is when x equals 0. So we would look for that on either our graph, or we could try to look for that in a table. Okay, versus b. B is our multiplication factor. Or, right, like the pattern that we were looking for. Pattern of y values. Pattern looking at, again, specifically our y values, right? So on like our, if we're given a table, it's easy to see looking at the y values, right? What's the pattern? How are we going from term to term, number to number? If we're looking at a graph, we would have to identify 2 of the points and maybe just like off to the side make a little XY table, right? Just to zero in on those y values and see what that pattern is. Okay. Oh gosh, I don't know how to erase everything, but this is just saying the y-intercept, the multiplication pattern, and I don't know, hold on, Alt-A. Okay, this is a great eraser tool. This is some high quality stuff here. All right, I might just stop here. Let me see what our next slide was. All right, we're gonna stop, pause. Okay, sorry about that. Took me a minute to find the clear all button. Okay, so we're gonna figure out how to write this formula based on a table that's given. We're gonna do this as a class. The next one you're gonna try on your own. Okay, so we've got our, equation off to the side. We're just gonna rewrite it too. Again, I don't have black for some reason. I don't know why, so I'm just gonna use green. So I'm sorry for the color coding fanatics out there. So f of x equals blank times blank to the power of x. So we want to write an equation based on this given data, right? So again, that a value that goes here, the a value is talking about our initial value, our y-intercept. Remember, our y-intercept is always when x equals 0. I mixed those up on the last slide, but same idea, initial value when x equals 0. And we're looking at our table over here, and we're trying to see where is x equal to 0. So if you see it while I'm erasing that circle, If you see it, go ahead and message in the room chat. Do we see on this table where x equals 0? Where x equals 0. All right. I'm assuming you guys are doing it. This is a recording, so I'm not sure. But when x equals 0, that's right here, y is going to be 3. So that's it. We just plug in 3. Boom. All right. Next, b times b to the power of x. b is the multiplication pattern, our rate of growth. How are we jumping from number to number? Again, focusing specifically on the y values. I can't remember, I'm not sure if I mentioned this before, but when we see this f of x, remember f of x is the same thing as y. It means the same thing. This is just another place in math where we're, it's the same, it means the same thing. There's a lot of different ways to say the same thing, and this is one of those examples. F of x, function of x just means y. If it's really confusing for you, you can cross out f of x and just write y. That's fine. Just know f of x means y. Okay, so thinking, what is the pattern? We know it's an exponential function, so we're going to be multiplying by some number. Room chat or private message, what pattern do you see? And I'll go ahead and pause the video while you're thinking about that. Maybe put a timer up real quick. Find the multiplication pattern and then let me know what you get. All right, so pause the video. Okay, assuming you guys sent it in. So we're seeing how are we, like bunny hops, how are we going from number to number? 3 to 6, 6 to 12, 12 to 24, etc. It looks like we are multiplying by 2. Yeah, multiplying by 2. So we're going to plug in a 2, and then that's it. This would be our final answer. This is our equation for this exponential function based on a table. We find the first term when x is 0, boom. What's the pattern? Plug it in, and that's it. All right, on the next slide, I want you to try it on your own. I'll put the timer up. Before we jump to the next slide, though, please add this to your notes in Engagely. For Engagely, click on Notes, click on Camera, add this to your notes, give me a reaction once this is in your notes, and then you'll try the next one on your own in a moment.